This is the second lesson of Modeling and Simulation module. This video has been developed by Dr. Sanjeewa Zondarangala, Senior Lecturer, University of Vocational Technology in Sri Lanka.
In first lesson, I discussed very basic commands in MATLAB. Now, we are going to discuss about matrix operations in MATLAB. Especially, I will focus matrix operation commands, which are useful for modeling and simulation module. Modern control engineering requires a lot of matrix operations, such as matrix multiplication, matrix inversion, calculation of eigenvalues. These operations are not easy to perform manually with higher order. MATLAB software provides a good platform to solve control systems problems related to matrix operations. Definition of matrix. If P and Q are positive integers, a P by Q matrix is a rectangular array. This matrix has P rows and Q columns. How to define matrices in MATLAB. Write all elements within square brackets. Use space or comma to separate elements of the row. Use semicolon to separate rows. As an example, let's have a look on a 3 by 4 matrix. This matrix has 3 rows and 4 columns. Elements of the first row are 1, 2, 3, 4. In second row 5, 6, 7, 8. In third row 9, 10, 11, 12. Now in MATLAB, matrices are usually denoted by capital letters. Therefore, here capital A is used to denote matrix. Equal. Now open the square bracket type elements of first row. 1, space, 2, space, 3, space, 4. Now type semicolon to separate first row. Then second row. 5, space, 6, space, 7, space, 8, type semicolon, 9, space, 10, space, 11, space, 12, close the square bracket, then enter. Now you can see defined 3 by 4 matrix. Column matrix. This matrix has only one column. Consider this column matrix. In order to define column matrix in MATLAB, type B equal, open the square bracket, 1, semicolon, 2, semicolon, 3, close the square bracket, then enter. This is a column matrix. Row matrix. A row matrix has only one row. Now consider this row matrix. To define row matrix in MATLAB, type C equal, open the square bracket, 1, space, 2, space, 3, close the square bracket, then enter. This is the row matrix. Null matrix. All elements of a null matrix equal to 0. Consider this 3 by 3 null matrix in MATLAB. To define 3 by 3 null matrix, type N equal Z E I or S within bracket 3, then enter. This is the 3 by 3 null matrix. For 2 by 3 null matrix, type N equal Z E I O S within bracket 2, 3, then enter. This is the 2 by 3 null matrix. Diagonal matrix. This is a square matrix with all elements of the diagonal equal to 0. Now, consider this diagonal matrix. In MATLAB, type D equal D I A G. Open the bracket, then open the square bracket. 1, space, 2, space, 3. Close the square bracket. Close the bracket. then enter. Now you can see diagonal matrix with given diagonal elements.
Identity matrix. In identity matrix, all diagonal elements equal to unity. See this example.
To define 3 by 3 identity matrix in MATLAB, type E, Y, E, open the bracket, 3, close the bracket, then enter. Matrix with random numbers. In order to generate a 3 by 2 matrix with random numbers, type A equal A, N, D, open the bracket, number of rows. In this example, it is 3, comma, number of columns, here 2, close the bracket. This is a 3 by 2 matrix with random numbers. In order to assign new value to any element in a matrix, use matrix name, within bracket, row number of the element, comma, column number of the element, equal, new value. As an example, if you want to assign 15 to the element in second row and third column of the previously defined matrix, type A, open the bracket, 2, comma, 3, close the bracket, equal, 15, then enter. This is the matrix A with the new element. Next command, to find the elements in all the rows of M column of a matrix. Use matrix name, within bracket, colon. Here colon is used for all the rows. Then type, comma, column number. As an example, again, consider matrix A. If you want to find all elements in third column, type A, open the bracket, colon, comma, 3, close the bracket, then enter. To find all elements in any row, use this command, matrix name, within bracket, row number, comma, colon. Now see this example. Type A, open the bracket, 2, comma, colon, close the bracket, then enter. This result shows all elements in second row of matrix A. Now, to show all the rows between selected 2 columns of the matrix A, use this command, matrix name, within bracket, colon, this colon for all the rows, comma, number of the selected first column, then, colon, this colon for the range. Now number of the selected second column. As an example, to show all elements of matrix are between second column and third column. Type A, open the bracket, colon, comma, 2, colon, 3, close the bracket, then enter. This results show all elements between second column and third column. Inverse of the square matrix. You can calculate inverse of a 2 by 2 matrix using this method. In MATLAB, it can be obtained by using single command. Type INV, open the bracket, A, close the bracket, then enter. This is the inverse of above 2 by 2 matrix. Determinant of a matrix. This is the calculation of determinant of a 2 by 2 matrix. This calculation is a little bit easy, but it is difficult with higher order matrix. It can be obtained easily using a MATLAB command. Let's have a look on determinant of a 3 by 3 matrix using MATLAB. Type D, E, T. Open the bracket, A, close the bracket, then enter. This is the determinant of the matrix. Matrix addition. Addition of the two compatible matrices can be obtained by getting addition of each of their respective elements. Here consider matrix A and B with same dimension. These two matrices are defined in MATLAB. Now,
Type A plus B. Then enter.
sum of two matrices with different dimension is undefined. Same procedure can be used for the subtraction. But multiplication of matrices is not as simple as addition and subtraction. In order to obtain multiplication of A and B matrices, the number of columns in the matrix A must equal number of rows in matrix B. In order to obtain multiplication of these two matrices, multiply first element of the first row of matrix A with first element of the first column of matrix B. Then multiply second element of the first row of matrix A with second element of the first column of matrix B. Continue this method to obtain multiplication of the two matrices bimanually. After defining the matrices to find matrix multiplication, type A asterisk B.
Then enter. This is the multiplication of A and B matrices.
Here, I focused important matrix operation in MATLAB. In next, I will discuss about the script files.